Okay, now we're recording. And share the screen. I'm getting set up. So again, we're on to one section a day, still. So let me take a look at our little mini calendar. Where we are. Okay, so we're here the 13th. So 10.3 today, 10.4 next time. Quiz on Thursday, it'll be on the material from today. In fact, I'll be even more specific, so I'll tell you exactly what it's going to be on when we get to that. Okay, so calendar for now is 10.3, 10.4 this week. Next week, 11.1, 11.2. And then our exam 4 is on Tuesday, the 27th. If you're looking in the book, there are a lot of other sections and chapters, but we're not required to cover them. So you might notice, hey, there's more sections in chapter 11 and so on. Yes, we're aware of that, but you can only cover so much material in a 3-unit course. So I'm not required to do the other sections, so we don't. Okay, so we're over here. So 10.3. All right, there are applied max and min problems. Okay, so in real life situations, you want to maximize the quantity or minimize the quantity. Okay, and so my goal as usual is to show you how to do at least one of each type. Okay, so I do one of each type, use that as a template to see how the other problems work. Okay. So I think we're going to do some absolute maxima and minima, absolute maximum and minimum on a closed interval. I'll show you how to do that. Okay, we're going to be doing stuff like minimizing costs or minimizing average costs, maximizing revenue, maximizing profit, that kind of stuff. Right? So normally when you operate a business, that makes good business sense, right? You want to minimize your costs, minimize your average cost perhaps, maximize your revenue, maximize your profit. Don't write any of this down. Once we start doing the problems, you'll see all that. Okay, so we're here. Next time is that. Then next Tuesday, next Thursday, and then the test. Okay, I probably don't need to remind you that much, but we're ending the semester pretty rapidly. Then after that, our last test only covers 4 sections, so it's pretty small. So we haven't had anything that small pretty much, so that goes by pretty quickly. Again, we're aiming for the last test. If I move everything up a day, I'm not going to write it in yet just in case I mess up somewhere, but I'm hoping for exam 5 to be Thursday, May 13th. We can do that if I can keep the schedule and push everything up a day. In which case that would be what, 12.1, 12.2, 12.3, 13.2, and then the last regular test. So then on the 18th of May, I can just make that a question and answer session, just review about anything we'll review for the final exam. And then Thursday the 20th, we take our final exam and then we're done. And we're done with the course. Okay, and of course, we're not doing this anymore. All right, so any quick questions about where we're headed before I start doing math? Okay, so let's start today's material then. Okay, so 10.3. Topic is optimization in business and economics. My page 655. Of course, I've got the 11th edition, which you may not have. Okay, so you want to maximize some quantity, you might want to minimize the quantity. Okay, first thing we're going to do, see where it says objectives, find absolute maxima and minima. Okay, 1 maximum, 2 maxima, showing you that. Other things, maximize revenue, minimize average cost, maximize profit, stuff like that. Okay. All right, so let's talk about absolute maxima and minima. On page 656, there's a very formal definition of absolute maximum and absolute minimum. I don't think you really need it. It's just the highest in the graph and the lowest in the graph. What they have is correct. There's nothing wrong with it. I would say don't even put it on your cheat sheet. It's not necessary. It's correct. There's nothing wrong with it, but you can survive without it. Just look at the graph. It's the highest point. It's the lowest point. Now, on page 656, they show us some computer generated graphs. Okay, figure 1028a, y equals x minus 1 squared. Okay, so you definitely see an absolute minimum down here. It's absolutely the lowest in the graph. So before we had relative maximum and minimum or local maximum minimum, absolute maximum and minimum. It's absolutely the highest point of the graph, or it's absolutely the lowest point in the graph. There's no point in the graph that's higher, and there's no point in the graph that's lower. Okay? Absolute extrema. See, what's extrema? It's either a maximum or a minimum. Okay, extrema is an extreme point, like a maximum is an extreme point, a minimum is an extreme point. Okay, so as opposed to relative maximum or minimum, we did last time, or local maximum minimum, okay, only within a small region, it may be the highest or lowest. But now we're talking about absolute maximum and minimum. Okay, they don't have to exist, by the way. So this graph, A, that parabola, there is no absolute maximum. It just goes up, 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 right? But there is an absolute minimum, looks like at the point 1, 0, right? Okay. Now, how about the second one? B. Take a look at this one. If you have a continuous function on a closed interval, like this, closed interval, you might have a maximum or minimum at the endpoints. That's the key thing, and the problems that I'm going to be showing you involve that. And that will give us the idea behind the quiz also. Okay, so this is the same graph as this, but only on a very small region. It's defined between 1/2 and 2, it looks like. Okay, so absolute minimum looks like here. Absolute maximum over here. Okay. Now, we know how to find maxima and minima, set the derivative equal to 0, right? But your maximum minimum point might be at an endpoint just because the graph either starts or stops there, right? So if I have a continuous function on a closed interval like this, closed interval from 1/2 to 2, including a half, including 2, your maximum minimum might be at the endpoint, as you can see right here, right? So that looks like absolute maximum. That looks like absolute minimum. Okay. Now the third one, same function, right? X minus 1 squared. They just cut off a lot of the graph. This closed interval is from 2 to 3. This time the maximum and minimum are both at endpoints. It doesn't look like you have a slope of 0 anywhere, right? It just goes up all the time. So that looks like absolute minimum. That looks like absolute maximum, right? All right, so what does that mean for finding maxima and minima on a closed interval? So that's 10.3, 1 through 4. Find the absolute maxima and minima. Again, maxima is the plural of maximum. 1 maximum, 2 maxima. You're not supposed to say maximums. Minima, plural of minimum. 1 minimum, 2 minima. Okay. There's only 4 problems. And so, I'll do the evens. And they give you a closed interval. Notice closed interval -1 to 3. Closed interval -3 to 1.5. -2 to 0, -0.5 to 2, and so on. Find the absolute maxima and minima. Okay, now we know how to find maxima and minima by setting the derivative equal to 0, right? But in this case, you also have to check the endpoints. You must plug in the endpoints. All right, now based on that, let me show you the algorithm or the steps you need to take for finding absolute maxima and minima. Okay, so it said 1 through 6. It's actually only 1 through 4 now. This is from a different edition. Let me change it to this. And I notice that's not even the same page number. So ignore that. I'll just do the problems. Okay, absolute max and min on a closed interval. Find the critical points. That's the same as last time, right? Take the first derivative, set it equal to 0. And you also have to set it equal to undefined technically, but they aren't going to give us any problems like that, and I won't either. Then you also have to check the endpoints. You must plug in the endpoints. Okay, so you have a list of points. You have all the critical points and the endpoints. You're guaranteed at least 2 points, the left endpoint and the right endpoint. Then you also check the critical points. So you have a list of points. The highest Y value is the absolute max. The lowest Y value is the absolute min. That's all there is to it. Okay, so I'll go through that again. Find absolute maximum and minimum on a closed interval. Find all your critical points. Set the derivative equal to 0. And find the endpoints. They will give you the X coordinates of the endpoints. You have to plug in to find the Y coordinates. So from that list of points, just look at the Y values. The highest is the absolute max, lowest is absolute min. Okay, so here we go. So I'll show you how to do a couple of them. And your quiz on Thursday will be exactly just like this. Okay, so again, I'll show you from even problems. Again, if your even problems don't match mine, it's okay. It doesn't really matter. The even problems don't have the answers in the back of the book anyway. The main thing is that you're learning something. All right, so f of x equals x cubed minus 3x plus 3. And the interval is from -3 to 1.5. Find the absolute maximum and minimum. Look at the directions again. Find the absolute maxima or maxima and minima on the closed interval. So they tell us to go from -3 to 1.5. So at this early stage of the game, I know for sure I have to plug in 2 numbers. Can you guess what those 2 numbers would have to be? You must plug in -3 and 1.5, right? You have to find the endpoints. Remember, this is an interval. These are only X coordinates. Both of these are X coordinates. It's on the X axis. Plug in to find a Y coordinate, plug in to find a Y coordinate, okay? And I also have to find the critical points. By the way, this order doesn't matter. You can find the endpoints first and then the critical points. Main thing is you get the list. All right, so let's take the derivative. So what's the derivative of this? 3x squared minus 3. Okay, set it equal to 0, right? The critical points, slope equals 0. So set this equal to 0. Factor out the 3. 3 times x squared minus 1. X squared minus 1 factors into x plus 1, x minus 1. Okay, set that equal to 0. By the 0 factor property, one of these has to be 0. 3 cannot be 0, of course, they're different numbers. How do I make x plus 1 equal to 0? X is -1. How do I make x minus 1 equal to 0? +1, so plus or minus 1. My critical numbers are plus or minus 1. And for sure, I already know I have to plug in these endpoints. So I have to plug in 4 numbers. Plus or minus 1, -3, and 1.5. And by the way, -1 and +1 are in this interval, right? They are between -3 and 1.5. But if your critical number lay outside of that, then you don't have to check it. So let's pretend you got x equals 2, right? Don't even look at it because they told you to only go from -3 to 1.5, right? Or suppose you got x equals -7, then throw it out because they said only go from -3 to 1.5. However, both plus or minus 1 are in this interval. Okay, so now you just plug in. Take all 4 of these. So notice -1, +1, and the endpoints, -3 and 1.5, all have to get plugged in. Okay, so I plug them into the original, x cubed minus 3x plus 3. Okay, and as usual, I won't take up class time to actually punch it in a calculator. You can punch it in a calculator as well as I can. But you plug in -1, -1 cubed minus 3 times -1 plus 3, which is -1 plus 3 is 5. Okay, so f of -1 is 5. Now I plug in +1 to the original. 1 minus 3 plus 3. 1 minus 3 plus 3 is 1. Okay, remember, when I write f, I'm giving a y coordinate. Okay, -3, a little bit harder. negative 3 cubed minus 3 times negative 3 plus 3. Okay. So that's negative 27 plus 9 plus 3 comes out to be negative 15. Well, 1.5 is the hardest, of course, so you have to punch that in the calculator. Okay, I'm willing to show you that on the calculator. So plug in 1.5 to the original. 1.5 cubed minus 3 times 1.5 plus 3. Supposedly it's 1.875. Okay, and when I just double check that right now in my calculator. So what am I doing here? 1.5 cubed minus 3 times 1.5 plus 3. There you go. So 1.5 cubed minus 3 times 1.5 plus 3, 1.875. Okay, so there we go. All right, so I have my 4 points. Negative 1 comma 5, 1 comma 1, negative 3 comma negative 15, 1.5 comma 1.875. Okay, so I look at the y values. Remember, these are y values. So which is the highest? Looks like 5. Which is the lowest? Well, only one of them was negative, this one, right? So I'm done. Absolute max, negative 1 comma 5. Absolute min, negative 3 comma negative 15. That's it. So I noticed one of them was at an endpoint. The minimum was at an endpoint, and the maximum was at a critical point. So you can't tell ahead of time whether your maximum is going to be one of the endpoints or the critical point. So you just have to try them all. Okay, so that's the idea. Okay, what am I showing you here? You don't really need this, but there's actually more graph. This is defined for all real numbers, but we're only considering from negative 3 to 1.5. So I was just illustrating here. We're throwing all of this out. We're throwing all of this out. We only care about the graph between negative 3 and 1.5. So only between negative 3 and 1.5, the absolute maximum is at negative 1 comma 5 somewhere. And the absolute minimum is the starting point, actually, negative 3 comma negative 15. Right? Right, that's the way it works. And I'll show you another one like that. But again, let's review the protocol because that's what you're going to get quizzed on this Thursday. Okay, so they're going to give you a closed interval and a function. So take the derivative, set it equal to 0. Find those critical numbers. And then you plug in the endpoints. So you get a list. So my critical numbers are plus or minus 1. Plug in negative 1 and 1. Plug in the endpoints, negative 3 and 1.5. So you have a list. 4 points, 1, 2, 3, 4. The highest y value, 5, absolute maximum. Lowest y value, negative 15, absolute minimum. Okay, so there we go. And the only other one I want to show you is this one. F of x equals 9 plus 6x squared minus x cubed. I actually don't even see this one in this book, but it's okay. We're still just loading the material, so just go with it. Negative 3, 10. Okay, so right now I'm for sure going to plug in what numbers? Hint, I'm pointing right at him. Negative 3 and 10. You have to plug into endpoints. Negative 3 and 10. Now the critical numbers. Okay, so take the derivative. Derivative of 9 is 0. Derivative of 6x squared is 12x minus derivative of x cubed is 3x squared. All right, factor out. Greatest common factor, GCF, is 3x. So take out 3x, parentheses, 4 minus x equals 0. Is that right? Double check. 3x times 4 is 12x. 3x times negative x is negative 3x squared. Okay. So set this equal to 0. What makes 3x 0? 0. And what makes 4 minus x 0? 4. So once again, in this case, I have 4 numbers to check. 0, 4, and negative 3 and 10. And by the way, double check, is 0 in here? Yes, it is, between -3 and 10. And is 4 in there? Yes. But let's pretend I got, I don't know, 13, then I throw it out. It's not between -3 and 10. Or suppose I got -4, throw it out. It's not between -3 and 10. Okay, so just plug in. Again, I won't take up too much class time on the calculation. You can look at how it's done, but check this on your calculator at home on your own. Plug in -3. 9 plus 6 times -3 squared minus -3 cubed. Looks like an equal sign. It should be a minus sign. Sorry. Make that look like a minus. All right, anyway, that comes out to be 90 theoretically. Let's see, -3 times 2 is 9. 9 times 6 is 54. 9 plus 54 is 63, minus a minus 27. So it's 63 plus 27, 90. Yeah, it seems to be correct. Okay, plug in 0. Oh, I like plugging in 0, right? 0, that's an easy one, right? Because 0 times anything is 0. 0 squared is 0, 0 cubed is 0. So it's 9 plus nothing minus nothing, 9. Okay, I just got a message that my internet connection is unstable, so don't be surprised if I accidentally get logged out. If I get logged out, hang in there. I'll try to come back as soon as I can. Okay, then I'm supposed to plug in what, 4? That's not as nice. 9 plus 6 times 4 squared minus 4 cubed. Okay, supposedly that's 41. 9, let's see, that's 6 times 16 is 96. 96 plus 9 is 105. 105 minus 64, 41. Okay, you can try it on your own, take my word for it. And 10. I think I'll actually show you the 10. 9 plus 6 times 10 squared minus 10 cubed. Well, actually, that's not that hard. See, 10 squared is 100. 100 times 6 is 600, isn't it? So that's 600. 10 cubed, 10 times 10 times 10 is 1,000. So 600 minus 1,000, 600 minus 1,000 is -400. Yeah, I don't need a calculator. And add 9, so -391. All right, so here's my list. Highest Y value, 90. So absolute maximum, -3, 90. Lowest Y value, the only negative one here. So 10, -391, absolute minimum. Okay, so that's the way you do it. All right, so that's that. Now we have some word problems, but that's basically finding absolute maximum and minimum. And then don't worry if your problems don't match mine. The main thing is that you're learning the material. Okay, but the quiz on Thursday will be just like that: maximize or minimize on a closed interval. But now we have other word problems. So I figured out on a quiz I wouldn't give you a word problem, right? I might give you word problems on a test, of course, but I decided not to for a quiz. But maximizing revenue. Of course, we always want to maximize our revenue whenever possible, right? So let's see. So my problem 8, the revenue function is 25x minus 0.05x squared. Okay, so that's a formula for the revenue for this company or whatever, finding maximum revenue. All right, so I'll take the derivative. First derivative, 25x, derivative is 25. Derivative of -0.05x squared. 2 times -0.05 is -0.10x. Set it equal to 0. Move that over, add 0.10x. 25 equals 0.10x. Divide both sides by 0.10. X is 250, my critical number. Now, how can I tell if I have a maximum or minimum? Okay, I could do a first derivative sign chart, but the second derivative sign chart is easier in this case. Okay, what is the second derivative? So the derivative of this is negative 0.1. That is less than 0. Okay, so from last time, second derivative negative means concave down. So if I have a slope of 0 and an upside down U shape, I have a maximum. So I've proven that I have a maximum. See, it's not technically good enough just to say set the first derivative equals 0. It might be a maximum, but it might be a minimum. So you can either do your sign chart or do the second derivative. Okay, the second derivative was negative. That means concave down from last time stuff. That means I have a maximum. All right, now it asks for the revenue, the maximum revenue. The question asks for the maximum revenue. So I just plug in. So I plug in 250 to the original. So 25 times 250 minus 0.05 times 250 squared. So plug 250 back into here. 3125. Okay, and I'm willing to spend some time on that. Might be willing to do it once in a while, but not all the time. See, 25 times 250 minus 0.05 times 250 squared. $25 times 250 minus 0.05 250 squared, 3125. 25 times 250 minus 0.05. I actually add an extra 0 here, but that's okay. That still works. Times 250 squared, 3125. You can see that. Right, so that's the maximum revenue. Okay. Now, part B is different. It says you can only produce between 0 and 200 items. Okay. So that's just like this. You're maximizing or minimizing on a closed interval. Okay. The most you can produce of this item is 200. The critical number was 250. That's outside of my range, right? So all I do is plug in the two endpoints. All right, so plug in 0, you get 0, which obviously makes sense. If you sell nothing, you produce nothing, then your revenue is nothing, right? Just sit around and nobody comes and buys anything, your revenue is 0. So the maximum must be at 200. You can tell that right away. Okay, so I just plug in 200, and that'll be the maximum in this case. So 25 times 200 minus 0.05 times 200 squared. I won't bother to show you the calculation for that. I'll just tell you it comes out to be 3,000. All right, so the maximum in this case, where you can only have a number between 0 and 200, is 3,000. Yeah, and I'm noticing that number is smaller than 3125, which makes sense, but that's under the case of maximum production where X is unlimited. You can let X be any real number. Okay. But in this situation, and that often happens in business, you can't churn out 250 of this item. Okay, your machines can only do a certain speed, and maybe you can only produce 200 at the most. Okay, so producing 200 at most, you can only make $3,000 a day instead. Okay. All right, so that's maximizing revenue. Okay, then next problem I'm going to show you is minimizing average cost. Page 663, minimizing average cost. So let me show you average cost formula on page 658. All right, now you can have a cost, but you can also have an average cost. Okay, simple example. Suppose I have a, something costs $30. And sorry, the total was $30 and I bought 10 of them, right? Okay, $30, I bought 10 of them. What's the average cost? 30 divided by 10, which is 3. right? So it's the total cost divided by the total number. So there it is, average cost. It's on my page 658. They write it as C bar. See that line over the C? We say C bar. It's C of X divided by X. It's the total cost divided by the total number of units. Okay, so the total cost function is C, or C of X. Then average cost, C bar, is C of X divided by X. So if they give me the cost function, average cost is C of X divided by X. And in some instances, that's really what you want to minimize. You're not so worried too much about the total cost. You're worried about the average cost, right? You know how when you go to the store and you buy something that says, oh, $10, or maybe it's, I don't know, $15 for two, right? So $15 for two is cheaper, right? You know how you go to the store, okay, something is $10, but if you buy two, it'll be only $15. Because the average cost then would be 15 divided by 2, 750. Okay. Now the total cost is certainly bigger. So of course, if you spend $15, that's more than if you spend 10. But the main idea is the average cost. The main idea is the average cost, right? The per average cost is 15 divided by 2, is I'm only spending 750 per item. Right? So sometimes you may not be interested in minimizing cost, but the average cost, right? And of course, a lot of stores do that. You know, the more you buy, the more we're willing to give you a discount, right? So the average cost goes down. All right. All right, so my problem 18, they give you the cost function, 300 plus 10x plus 0.3 x squared. Okay, so the first thing I have to do is find the average cost, C bar. If you can't read that, that says C bar, C B-A-R. It's the average cost. So all you do is take the original function and just divide it by x. Okay, so the function they gave me was 300 plus 10x plus 0.03 x squared. Divided by x. So 300 divided by x is 300 divided by x. Plus 10x divided by x, x cancels out, I have 10. Plus 0.03 x squared divided by x is 0.03x. Okay, and we're trying to minimize this quantity. And something else we need to say, for these kind of things, we only want positive values. We're selling something. There's no such thing as selling or buying negative items, right? So we don't want x to be a negative number. We don't even want it to be 0. Okay, so x should be a positive quantity. Okay, so I'm trying to minimize this quantity. All right, so one more time, they gave me the costs. I want to minimize the average cost. So the first thing you do is divide by x. So I ended up with this. So this is the thing, C bar is the average cost. That's what I'm trying to minimize. All right, now I don't want to do the quotient rule, as you know. So again, anytime you have a constant on either the top or the bottom, simplify it. So 300 over x should be thought of as 300 x to the negative 1. That way I don't have to do the quotient rule. Now, would the quotient rule work? Yes, it would, but that's more work. I don't want more work, I want less work. Okay. So I'm going to take the function as 300 x to the minus 1 plus 10 plus 0.03x. Okay, so now I'm finally ready to go. All right, so C bar prime, first derivative is negative 1 times 300 is negative 300, x to the negative 2. And the derivative of 10 is 0. And the derivative of plus 0.03x is 0.03. And yes, I'll be setting that equal to 0 in just a second. But let me go straight to the second derivative analysis. Second derivative. Okay, now I know the derivative of 0.03 is 0, so forget about that. What's the derivative of negative 300 x to the negative 2? So negative 300 times negative 2 is a positive 600 x to the negative 3. Okay, algebra, that's 600 divided by x cubed. And for my analysis over here, I already said that x is definitely greater than 0. which means no matter what number I plug in for x, this is going to be positive. That's true for all x greater than 0. Positive second derivative. Positive second derivative means concave up. So I drew myself a tiny little concave up situation. Whenever the first derivative is 0, I'm going to have a minimum. So that proves that I am going to have a minimum. Was I looking for a minimum? Yes, I was looking for a minimum. I'm going to get a minimum. So I get what I want, essentially. All right, so I'll set the first derivative equal to 0, and then I'll be home free. Better for algebra to rewrite this as negative 300 over x squared. So I'm going to write negative 300 over x squared plus 0.03 equals 0. So that's this over here. Okay, I will move this over there, add 300 over x squared to both sides. So I have 0.03 equals 300 over x squared. Multiply both sides by x squared, include the fractions. 0.03 x squared equals 300. Divide by 0.03, cancels out. 300 divided by 0.03 is 10,000. X squared equals 10,000. Take the square root. X is 100 items. Okay, so I can minimize the average cost, not the cost, but the average cost if my X is 100. Okay, now the problem asks, what is that minimum cost? I take the 100 and plug it back in to here. Not the original. The original is the total cost. I plug into the average cost function. So plug in here and here and here. C bar of 100. So 300 plus 10 times 100, 10x, plus 0.03 100 squared divided by 100. Okay. Punch that out, comes out to be $16 per unit. So that's the minimum average cost that I can have. Okay. So there we go. All right, so that's how to do a minimum average cost problem. I'll go through the protocol again. They will give you a cost function. You want to minimize the average cost. So first you divide the original by x. Work it all out. That's what you're trying to minimize. I took my first derivative. I took my second derivative. The second derivative turned out to be greater than 0 all the time. Second derivative greater than 0 means I have a minimum because I have a concave up situation. Now, the previous problem, we had a concave down situation, which means I have a maximum, right? Slope is 0. I'm going to set the slope equal to 0, the first derivative equal to 0. Concave down means I have a maximum. You can see from this picture, right? Concave down, upside down U shape, maximum. Concave up means I have a minimum. All right, so I have a minimum. I set that equal to 0. I got x equals 100. Plug 100 back into my C bar function. And so my minimum average cost, not the minimum cost, but the minimum average cost was $16 a unit. Okay, so I just have one more type of problem and then I'm done, but don't get your hopes up too high. It takes a little bit longer to develop this problem, but we'll still finish early. No question about it, unless anybody wants to ask questions. Okay, last thing we want to do is maximize profit, right? Of course, we all want to maximize profit. So how do I maximize profit? Okay, now they might give me a revenue function and a cost function. Okay, like for 27, which is not the problem I'm doing, but R of X is a revenue function, C of X is a cost function. Okay, now the problem I'm actually going to do is my 30 cost function. R is a revenue function. All right, so the cost function they give me is 800 plus 100 x squared plus x cubed. the revenue function they gave me is 60,000 x minus 50 x squared revenue. The directions are to maximize the profit. Profit is revenue minus cost, right? You should already know that sort of, but you know, if you're in business, even for yourself as an individual, right? For yourself as an individual, you have a month, say, how much money did I make this month? Well, what's my revenue, right? How much money came in from my work, presumably, or whatever, minus all of my costs, right? My rent, my mortgage, my food payments, my house payments, my phone bill, or whatever, right? That's considered profit. Or if you have a business, some of you maybe have a business, you always have to consider both of these, right? How much money am I taking in, and minus how much do I lose, my costs, and that's considered profit. Okay. So you can put this on your cheat sheet, but I don't think you need to, but if you want to, you can. Profit equals revenue minus cost. I think you all know that, but just in case, I'll write it down. Profit is revenue minus cost. And of course, if you're in business, especially, you hope that's a positive number. If it's a negative number, you're losing money because the amount coming in is smaller than the amount going out. They could be equal. That's called break even, right? Break even means, okay, the amount that's coming in and the amount that's going out is exactly equal. You don't have to write that down if you don't want to. I'm not testing you on that, but break even means, you know, revenue equals cost. Okay, so anyway, I take the revenue function, here it is, subtract, and this is one thing you have to watch out for. When you subtract, it has to be in parentheses. You're subtracting the whole thing. So here's the revenue function, 60,000 x minus 50 x squared, minus parentheses 800 plus 100 x squared plus x cubed. Okay, and yeah, the first time I did it, I messed up, but I think I got it now. So negative x cubed minus 150 x squared. Now, how did I get that? There's a minus 50 x squared, and there's another negative 100 x squared. So negative 50 minus 100, negative 150 x squared. Plus 60,000 x minus 800. So I think everything's accounted for. Okay. The only two terms that combine are the x squareds, right? That one and that one. Negative 50 and a negative 100. Negative 150. Everything else is singletons. Negative x cubed, positive 60,000 x, and minus 800. Okay. So I want to maximize this quantity. And again, for this kind of word problem, x should be greater than or equal to 0. Okay. You can't sell or buy negative quantities. Right. So first derivative, negative 3x squared minus 2 times 150 is negative 300x plus 60,000, and the derivative of negative 800 is 0. Okay. And yes, I'll be setting that equal to 0 in just a moment. But let me do the second derivative analysis again. Second derivative is negative 6x minus 300, and the derivative of 60,000 is 0. It's a constant, right? Now, it doesn't matter what number I plug in, because I'm only plugging in x greater than or equal to 0, right? Strictly speaking, x is 0 is allowed. I mean, then you're really selling no items. But even if you plug in 0, you get a negative number. And if I plug in any positive quantity, do you agree this is going to be negative, right? If I plug in 1, 2, 3, a billion, this whole thing is going to be negative. It doesn't matter what I plug in for any positive quantity. So second derivative less than 0, that's just like this one over here, right? Second derivative less than 0, concave down. Concave down means I have a maximum. CD. Right, so remember last time, concave down, upside down U shape. So if I have a concave down situation, how do I know if I have concave down? Second derivative negative. So that means I have a maximum. The previous problem, second derivative positive, concave up, U shape. So at the place where the slope is 0, I have a minimum. All right, so I'm home free if I just set this equal to 0, and then I'm done. So my first derivative was this, negative 3x squared minus 300x plus 60,000 equals 0. Okay. Factor out the common factor of negative 300. Negative 3, sorry. So x squared plus 100x minus 20,000 equals 0. All right, factor. This factors in x plus 200, x minus 100 equals 0. Okay, you double check with FOIL. If I FOIL this out, x squared minus 100x plus 200x, that's positive 100x, and 200 times negative 100 is negative 20,000. So it works. Okay, so what makes this 0? Nothing. Negative 3 can't be 0. What makes this 0 is negative 200. I immediately throw it out, right? Because how can you sell negative 200 items, right? No such thing. Doesn't make sense. And so x equals 100. So x equals 100 will maximize the profit. Okay, and I just left it at that. I'll let you figure out the rest. You can plug it in. But to maximize the profit now, just plug in x equals 100 to p of x, and I'll let you do that on your own. Okay, so 100 goes, officially the problem's not finished. We'll just plug it back into the original profit function. Let's see where to go. Right here. So put 100 here, 100 here, 100 here, grind it all out. That's your answer for the maximum profit. Okay, so I'll let you do that on your own. And there we go. So that's the technique for maximizing profit. Okay, so folks, I'm done. Let me do my focus thing, and otherwise I'm finished. So after I finish my focus thing, which will just be a few seconds, if you have no questions, then we're done. Okay, and so next time I will give you a quiz. We'll do a new section, of course, 10.4, which is on more word problems. Great, right? More applications of maxima and minima. They're all word problems, as you can see. Word problems, word problems. Okay, but again, you're going to try to maximize or minimize fencing, minimum cost, or whatever, right? So we'll be doing more of that next time, and then I'll give you the quiz. The quiz will definitely just be on the first part there, 10.3, 1 through 4. Absolute maximum and minimum on a closed interval. Okay, so you'll be plugging in the two endpoints, and then you have to plug in any critical points, right? And then the highest point will be the absolute max. Lowest point is the absolute min. Okay, so let me do my focus thing again, and then that's about it. Okay, again, ignore any dates, ignore the section numbers. Okay, the page numbers may not even be correct, depending on the edition of the book that you have. So that, okay. So you can always go back and look at the video. All of these things. You usually get about 3 columns per paper. And the last one, in case you didn't get the focus there. Remember, if you're saying I'm going too fast, you can always look at the video and, pause, fast forward, rewind as much as you want. And there we go. The last thing again for this problem 30, I didn't quite finish it. You do have to plug in to get the profit. But that's easy, just use your calculator. Plug in 100 to the profit function. Where'd it go? Right here. So negative 100 cubed minus 150, 100 squared, plus 60,000 times 100 minus 800. And that's the maximum profit. Okay, I'm finished, folks. Any questions? Pause for a moment for you to say something or put it in the chat. Okay, I don't see or hear anything, so we're done for today, folks. All right, so we'll see you next time then. Oh, sorry, there is a chat. Okay, some people just showed up. Yeah, I got it. Anybody who came late, please put your name in the chat right now. Yeah, and I got it. Otherwise, we're done for the day. All right. Okay, that's it, folks. Have a good rest of the day, and we'll see you later. Okay, bye, everybody.
Thank you.
Okay, bye.